Hi everyone, today we are talking about absolute value. As a reminder, you do not need to write down everything that we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you already got it. Just be careful, make sure you don't fast forward too much that you end up missing out on something important. Let's get started. So we'll start off with what absolute value even is. Now would be a good time to pause the video and jot down this information before moving on. So absolute value is a number's distance from zero. So what we mean by that is the amount of spaces it would take for us to get from your number to zero. Now keep in mind that a number can either be positive or negative. So in this case, we want you to ignore the sign because the positive or negative just tells you the direction the number is from zero. All your positives are on the right-hand side, all your negatives are on the left-hand side. But that's not what absolute value wants from you. Absolute value just wants the distance, doesn't care about the direction. So you just want to look at the number. The number tells you the distance. So you're going to ignore the positive or negative sign. And absolute value is represented by these long bars outside of the number. So for example, the absolute value of -5 is written with -5 inside two long bars. The other important thing to remember about absolute value is that it's never a negative value because we're looking for distance. Distance is never negative. I would never tell somebody that I'm -3 miles away. I say that I am 3 miles away. So absolute value is positive because distance is positive. The only case where it's not positive is if somebody's asking you the absolute value of zero itself, because zero is neither positive or negative. If I wanted to know the absolute value of zero, then it's zero, because zero is 0 spaces away from zero itself. It's already there. So as an example, we have +4 and -4. And we want to know the absolute value. The absolute value of +4 is 4. It's 1, 2, 3, 4 spots away from 0. So that answer is 4. And the absolute value of -4 is also 4 because it's 1, 2, 3, 4 spots away from 0 as well. It's just going in the different direction. But again, for positive value, we don't care about the direction. We just want to know the distance. So both the absolute value for 4 and for -4 is 4. 4 spaces away. It's kind of like if somebody were asking you how far away you are from picking them up. They don't care where you're coming from. They're just like, how far away are you? They don't need to know if you're coming from the north or the south or the east or the west. Just how far away are you? So that's just one positive number. So again, make sure you have this jotted down before we go on to examples. Okay, here is an example. We want the following inequality to be true. This right here has the bars, the absolute value bars. So we want to know the absolute value of x. And we want the absolute value of x to be, this is a greater than sign because I'm reading it from left to right, and I see the bigger side first. The absolute value of x greater than, this is the absolute value of 5. So I'm just writing it out in words. That's all what that says. They want the absolute value of x to be greater than the absolute value of 5. And they want to know which of the following are possible values for x. Choose all the answers that apply. Go ahead and pause the video and try it on your own first. Okay, So remember that absolute value is the distance away from 0. So they want to know the absolute value of x, a number that would go inside these absolute value bars. That absolute value needs to be greater than the absolute value of 5. The absolute value of 5 is 5. 5 is 5 spots away from 0. So we can already change that to a positive 5. Which one of these numbers, when put in here, would give you an absolute value that's greater than 5? Let's try these out. Well, if I put -4 into the absolute value bars, I would be looking for the distance of -4 away from 0. Well, -4 is 4 spots away from 0. If I put it into the 3 into the bars, I would want the distance of 3 away from 0. Well, that's just 3. And if I put 9 into the absolute value bars, it would be how many spots away 9 is from 0. Well, it's 9. Okay, so we want to know, is it 4 greater than 5 after you put in the absolute value bar? Is it 3 greater than 5? Or is it 9 greater than 5? So you are left with C as your only answer. So again, once you put it into the absolute value bars, it becomes positive because they're just asking you for the distance, and distance is always positive. So the answer would be C. Only 9 would work. -4 is fewer spots away from 0 compared to 5. 3 was fewer spots away compared to 5. Only 9 was the most spaces away from 0 compared to 5. Let's try another one. This problem tells you that b is equal to -5. They want you to move the dot to -b on the number line. Go ahead and pause your video and try it on your own first. Okay, so this is a review of number opposites. If b is equal to -5, what would the negative of b equal to? Well, it would be the opposite of -5 because all I did was put a negative in front of there. If positive b is equal to -5, then negative b would be its opposite, so it would be 5. So you should have your dot right between 4 and 6, which is where 5 is. Let's try another one. Water freezes at 0 degrees Celsius. Mano's water is 3 degrees Celsius. Leo's water is 7 degrees Celsius. Whose water matches each description? Is at a greater temperature and is closer to freezing. Go ahead and pause the video and see if you can try it on your own. Okay, so we see that Mano's water is 3 degrees Celsius. It doesn't have a sign in front of it, so we know it's positive. Leo's water is 7 degrees Celsius. Also no sign, so we know it's positive. And it says that water freezes at 0 degrees Celsius. So that's important information. Okay, so Mano's water is 3 degrees Celsius. That means his is right here. Leo's is 7. So whose water is at a greater temperature? Mano or Leo? Well, the greater one would be the one closest to the right because numbers get bigger as they go to the right. So it would be Leo at the greater temperature. And whose is closer to freezing? Well, Mano's is 3 spots away from water freezing, while Leo is 7 spots away from water freezing. So Mano's would be closer to freezing. So this one really wanted you to look at the distance things are away from 0. If it's further away from 0 and to the right, it's going to be greater. If it's closer to 0, then it's going to be closer to freezing. All right, this problem gives us A, B, C, D, and E on the number line. They want you to know what can we say about point E, and you want to choose all answers that apply. So it could be more than one answer. Pause the video and try it on your own first. Okay, so we want to choose the ones that are true. Is it true that E is equal to C? Is E equal to C? Well, C is 0. Looks like D is 1, then 2, then 3. So is E equal to C? Well, C is 0 and E is 3. So those are not equal to each other. They need to be right at the same spot. Okay, the next one says E is equal to negative A. Well, E we have as 3. Going to the left would be going in reverse order. So is E, 3, equal to negative A? Well, A is negative 3, so negative A would be the opposite, which would be equal to 3. Yeah, that would work. But we have one more to check. E is the opposite of B. Is E the opposite of B? Well, the opposite of B would be positive 1. And so it looks like E is not the opposite of B. Looks like the opposite of B is equal to D. So that one does not work. Looks like it's just B. So you got to be really careful about where things are in relationship to 0, because remember, opposites mean they're on the opposite side, same amount of spaces from 0. Okay, let's try this problem now. Use the following number line to determine if the expressions are true or false. So we have A and B. I notice that they're both on the left-hand side of 0. And we have 3 different statements, and we have to figure out true or false. Pause your video and try this on your own first. Okay, so this is what I would do to figure things out. There's no numbers here, so I'm going to give them numbers. B, I'm going to say is negative 1, because it's to the left a little bit of 0. And for A, I'm going to say it's like negative 3 or something. It looks a little bit further over. Doesn't really matter. I just made these numbers up. So now they want to know, is A less than B? A is negative 3. Is that less than negative 1? Is negative 3 less than negative 1? Yes, because if I owe $3, I have less money than someone who only owes $1. So that's true. It's further to the left compared to B. Now we have, for the next one, absolute values. So remember, absolute value just tells you the distance away from 0. And remember, we made up these numbers, so we're going to use them. The absolute value of A, which is negative 3, is that less than the absolute value of B, which we said was negative 1? Let's see. The absolute value of negative 3 is 3. Negative 3 is 3 spots away from 0. And then absolute value of negative 1 is 1. It's only 1 spot away from 0. Is 3 less than 1? Let's see. Here's 1. Here's 2. Here's 3. 3 is not less than 1. 3 is greater than 1. So that one's false. Okay, so we're going to do that last one now. And remember, we're using the values that we came up with. For this one, they want to know the absolute value of A, which is negative 3. Is that less than just the normal B, negative 1? Well, let's solve this absolute value first. Absolute value of negative 3 wants to know how many spaces away from 0 that is. Negative 3 is 3 spaces away from 0. So they want to know, is 3 less than negative 1? Well, 3 is over here, and negative 1 is over here. 3 is greater than negative 1. So this one is false as well. So you have a true, false, false. Okay, so that's as difficult as these absolute value questions will get. You just have to know if it's inside the absolute value bars. They want to know the distance it is away from 0. So you're going to change that number into just a normal positive number, because that's what they want. They want the distance, the amount of jumps it takes to get to that number. And then you can compare the two numbers. So in this last problem, they're basically just comparing the distance A is from 0 compared to just where normal B is. So one is asking for the distance and the other is the normal position. So you just have to be aware that sometimes they mix them up for you. And remember, absolute value is always positive. So negatives will change to positive, and positive numbers will stay positive because a normal 3 is just 3 spots away. Okay? Let me know if you have any questions as you work on these, and I'll see you in class.